The CPU switches between process to process. Suppose CPU executing a particular process, an interrupt occurs. That particular context of that process is saved in process control block, and CPU switches to the another process. This is called context switching. When an interrupt occurs, the system needs to save the current context of the process currently running on the CPU so that it can restore that context when it is processing is done, especially suspending the process and then resuming it. The context is represented in the PCB of the process. In PCB includes the value of CPU registers, the process state, and memory management information. Generally, we perform two operations, that is state save and state restore. State save saves the current state of the CPU and it put it in the kernel or user mode, and then state restore to resume the operations. Just I'll repeat what is the meaning of state save and state restore. Generally, we perform a state save of the current state of the CPU, be it in kernel or user mode, and then state restore to resume operations. When a process creates a new processes, two possibilities exist in terms of execution. The parent continues to execute concurrently with its children. Number two, the parent waits until some of all of its children have terminated. There are also two possibilities in terms of the address space of the new processes. Number one, the child process is a duplicate of the parent process. It means it has the same program and data as the parent. Number two, the child process has a new program loaded into it. Now let us see, using Unix operating system, the fork system call is used to create a new process. A child process can be created using fork system call. This exec system call used after a fork to replace the process memory space with a new program. These two are system calls we used. Let us see with this in an example. Here in this program we are used two system calls. One is fork system call. The second system call is exec system call. This is exec LP is later version of this command. This fork system call creates child process, where exec system call loads a binary file into memory and starts its execution. Okay, let us see this example. This is here in this case PID an integer value. This integer value always PID means process ID. See, this particular process created child process. Fork means whenever you invoke a fork system call, a child process is created for the parent process. If PID is less than 0, error. As soon as the fork process is created, my dear friends, parent process and child process both will parallelly execute. Since we created a new process using fork system call, it starts execution. And similarly, parent is also starts execution. And parent will wait until fork terminates. Let us see. If PID is less than 0 means it is a negative number, means it is fork not invoked. PID should be less than equal to or greater than 0 means child process is created. If more than that, it's a parent. Less than means negative means child process not created. If PID is equals to 0, then child process existed, and we are using this exel command here, and this will be executed by the child. Meanwhile, you see this part, parent process, since parent also executes parallelly, parent waits until child process completes a else part. Okay, this programs gives a very good example for fork and ELEC system calls. This is a process tree in Unix system. This is a root or main process. From this, three processes child process created, INIT. From INIT is responsible for the user processes. Here we have seen that user 1, user 2 and user 3. From user 3, like this we can create any number of child processes. Only one thing is, parent process terminates only if child process completes its job. Let us discuss about process termination. A process terminates when it finishes executing its final statement and asks the operating system to delete it by using exit system call. At that point, the process may return a status value, typically an integer, to its parent process via the wait system call. Because parent should know which one is terminated, which one is exit. All the resources of the process, including physical and virtual memory, open files, and IO buffers, are deallocated by the operating system. Parents may terminate execution of a child process in following situations and following reasons. Number one, child has exceeded its usage of some of the resources that it has been allocated. Second, the task assigned to the child is so no longer required. The third one, the parent is existing and the operating system does not allow a child to continue if its parent terminates. Because of these three reasons, a parent may terminate its children. Next we will see what is the cascading. In some of the systems, does not allow child to exist if its parent has terminated. In such systems, if a process terminates either normally or abnormally, then all its children must also be terminated. This phenomenon is referred as cascading termination. It is generally normally initiated by the operating system. We have seen in a previous example, A process execution and a termination. Consider in Unix, we can terminate a process by using exit system call. Its parent process may wait for the termination of a child process by using the wait system call. The wait system call returns the process identifier of a terminated child so that the parent can tell which of its possibly many children has terminated by knowing that identifier. If the parent terminates, however, all its children have assigned as their new parent the init process. If suddenly parent terminated, then our children will become parentless. Then a new parent is assigned, that is called init process. That the children still have a parent to collect their status and execution statistics from init parent. Let us discuss about inter-process communication. In that, now we'll discuss cooperating processes. In that, there are two types: independent and independent processes and cooperating process. Let us independent processes. A processes executing concurrently in the operating system may be either independent processes or cooperating processes. These two processes are maybe concurrently executes: independent processes and shared process, cooperating processes. A process is independent if it cannot affect or be affected by the other processes executing in the system. Any process that does not share data with any other process is called independent process. Now see what is cooperating process. A process is cooperating if it can affect or be affected by the other processes executing in the system. Clearly, any process that shares data with other processes is a cooperating process, where cooperating process can share its data with the other processes. There are several reasons for providing environment that allow process to cooperate. So cooperation is most important because the memory is shared with several processes. All these processes need same resources, same type of data each and every process may require. If they cooperate each other, we can save lot of resources. Okay. The advantage of process cooperation is: number one, information sharing; number two, computation speed up; number three, modularity; and number four, convenience. Now we will see that each one we'll discuss now. We'll discuss about what is information sharing. Since several users may be interested in the same piece of information, for instance a shared file, we must provide an environment to allow concurrent access to such information, that is information sharing. Same file is used by several processes. Second, computation speed up. So suppose we want to a particular task to run faster, what we'll do is we must break it into subtasks, smaller tasks, each of which will be executing in parallel with the others, so that if we do like that, the speed will be increased. The task can be completed in much faster rate. Third one, modularity. We may want to construct the system in a modular fashion, dividing the system functions into separate processes or threads. So this is very useful thing. A big system is there, we can design it into modular fashion, dividing into a system function. Each function can be act like as a separate process or a thread. Fourth one is convenience. For individual user may work many tasks at the same time. For instance, editing, printing, compiling in parallel. All these are for individual user convenience. Okay, that is the reason generally a cooperating process is very good. It saves the resources. In cooperating processes, the example of the cooperating process is producer-consumer problem. Here one process produces, the another process consumes. Here we will see what is the cooperation between these processes. If producer process is not produced, then consumer should not consume. If producer process is produced, then consumer then immediately can consume. We can take and for the execution. Sometimes there is no space. Producer is producing, you don't know where to keep. Its buffer is full. So producer should not produce, he should stop. Next, the consumer, if it want, if you look at the buffer, when buffer is empty, he should not consume. Means there is no item in that. Producer still not yet produced. So consumer should not receive or remove an element from the buffer. So both processes should synchronize each other or cooperate each other. This is a very good example, producer consumer problem. This we have two sizes here, unbounded buffer and bounded buffer. In unbounded buffer places no practical limit on the size of the buffer, whereas bounded buffer assumes that there is a fixed size buffer. Okay. If you see this code, producer use this code. Producer call this method public abstract void insert. The buffer is same. Using insert method, he is going to put that item. Consumer uses the remove public abstract object remove. This is remove method is used by consumer and insert method is used by the producer. The solution for this, let us discuss. It is a producer-consumer problem, uses a shared memory. To allow producer and consumer process to run concurrently, we must have available a buffer of items that can be filled by the producer and emptied by the consumer. This buffer will reside in a region of memory that is shared by the producer and consumer processes. The producer can produce one item while the consumer is consuming another item. The producer and consumer must be synchronized so that the consumer does not try to consume an item that has not yet been produced. The two types of buffers, one is unbounded and bounded buffer. We are going to use only bounded buffer. Bounded buffer means limited memory size we are taking. Let us see. The shared buffer is implemented in a circular array with two logical pointers. One is in, second one is out. The variable in points to the next free position in the buffer. Out points to the first full position in the buffer. The buffer is empty when in is equals to out. The buffer is full when in plus 1 mod buffer size is equals to out. Based on this algorithm, we can concurrently run producer consumer processes. This is how consumer process executing the code. We'll discuss about inter-process communication. In these two things we need to discuss. One is shared memory systems, and number two, message passing systems. Now let's see that what is the inter-process communication. Cooperating process require an inter-process communication mechanism, IPC, that will allow them to exchange data and information. We have seen bounded producer-consumer problem. Both have the same buffer. Producer, consumer, both are sharing the same buffer. That is the exchange of data and information. There are two fundamental models of inter-process communication as we discussed earlier. Number one is shared memory. Number two, message passing. In the shared memory model, the region of memory and is shared by cooperating processes is established. So shared memory first of all should be established. In producer consumer problem, a buffer is established. Processes can then exchange information by reading and writing data to the shared region. In the message passing model, whereas in the second method, message passing model, communication takes place by means of message exchanged between cooperating processes. Okay. Now let us see the message passing system. In message passing provides a mechanism to allow process to communicate and to synchronize their actions without sharing the same address space, and in particularly useful in a distributed environment where the communicating processes may reside on a different computers. Consider, for example, in the network, in chart program used in the World Wide Web, the one participant lives in somewhere, the other participant lives in somewhere in the part of the world. The message passing facility provides at least two operations. Number one is send message, and number two, receive message. Message can be sent and received. For example, there are two processes P and Q want to communicate. They must send messages to and receive messages from each other. A communication link must be existed between them. The link can be implemented in a variety of ways. We are concerned here with only logical properties. That is, implementing the link with logical, with send receive operations. One is direct or indirect communication, synchronous or asynchronous communication. Number three, automatic or explicit buffering. So if the following the questions we need to consider how are links established. From the sender to the receiver, we have seen that link to be needed. One is sender and the receiver. How are links established? Can a link be associated with more than two processes? Generally, link is associated with two processes from sender to receiver. Can a link is associated with more than two processes? How many links can there be between every pair of communicating processes? Generally use one link. Is there any more links? What is the capacity of a link? Next criteria is the size of a message that the link can accommodate fixed or variable. How much the size, the message size is fixed or variable. Is a link unidirectional or bidirectional? These are the points, my dear friends. These are the questions we have to answer for. Let us see a few things in direct communication. What happens? Processes must name each other explicitly. Suppose you are send a message to a process P. Your sender means you should know to which process you are sending. A receiver receives a message from process Q. This is comes under direct communication. Properties for communication link. Links are established automatically. When these two processes are interested to have a communication, the link is established automatically. The link is associated with exactly one pair of communicating processes. Between each pair, there exists exactly one link. The link may be unidirectional, but is usually bidirectional. It means is unidirectional. In general, it will be bidirectional, means both ways it can communicate. This comes under direct communication. What is comes here is indirect communication. Messages are directed and received from mailboxes. Here, mailboxes are created. So, sender and receiver directly will not contact each other. Via mailboxes, they are going to communicate. Each mailbox has a unique ID. So, sender is sending a particular process, means he is sending to process mailbox. Sometimes mailboxes can be handled by the process or else operating system. Processes can communicate only if they share a mailbox. Both should know the mailbox number, then only both can communicate each other. Next, properties of a communication link. Link established only if processes share a common mailbox. A link may be process associated with many processes. Each pair of processes may share several communication links. Link may be unidirectional or bidirectional. Operations. Create a new mailbox should be created by a process. Send and receive messages through mailbox only. This is indirect communication. After completing of the job, we need to destroy a particular mailbox. Here primitives are send. Here is address of the mailbox. So send a comma message, receive a comma message received from particular mailbox. Okay.